So, because it is so warm on Venus, after billions of years, scientists did not expect to find sharp features on Venus because the rocks would sag under all this heat, of course, over time. But instead, we found not only sharp, uneroded features, there are very distinct, sharp mountains.
Showing the billions of years are non-existent. They're only assumed.
Exactly. And overall, Venus does not have any of the features that you would expect if it were billions of years old. There's a scarcity of impact craters, for example. If Venus had been sitting there for billions of years getting bombarded by objects from space, we would expect to see a lot more craters than are actually there. The neighbor of Venus is our home, Earth. Obviously, the Earth is very special to us, and I know that you've spent quite a bit of time on the program already discussing the many reasons to believe that the Earth is young. But from an astronomical perspective, the Earth as a planet has a magnetic field as well.
Very interesting magnetic field.
A very, very interesting magnetic field. Again, the evolutionary model requires there to be motions inside of, fluid motions inside of our core, which the Earth does apparently have. However, there's a real problem in getting their model for magnetism to work. This is called the dynamo theory, and it's a complicated mathematical problem, but they haven't quite solved it yet, so we really don't know from an evolutionary perspective why the Earth should have a magnetic field, or could have a magnetic field, after billions of years. The reason I'm bringing this up is because, as you might have discussed here before, our magnetic field is decaying.
Yes.
And the energy in the field decreases every 1,400 years or so. It's reduced by 1/2. Now, if you look backwards in time, that means every 1,400 years you go, it's twice as strong again.
This is very important. Please continue with your emphasis.
And there's a definite limit as to how strong that field could have been. When you calculate this back to see how much it could have been, you wind up with a maximum age for the magnetic field, and therefore the entire Earth, of only about 20,000 years.
Yes, yes. And applying this to the other neighbors in toward the sun, they, as you've already indicated, have magnetic fields.
Actually, Venus does not, which is interesting too. Evolution says if these planets developed at the same time, at the same place, and the same materials, with the same natural processes, you would expect them to be very similar.
Yes.
But there's drastic differences that we haven't even had time to discuss between these two planets.
Major problem for evolutionary theory. Now, take us beyond our planet Earth.
Well, here we have our moon, and there's a number of reasons to believe the moon is young. One we can focus on for today is the fact that the moon raises tides on the Earth. Part of that process, and it's more detailed than we need to go into, the moon is moving away from the Earth ever so slightly every year. We've measured this with lasers now. And we have this is actually predicted before we measured it, so we understand why it's happening and how it's happening. The problem for evolution becomes that when you work this backwards in time, the moon would have been touching the Earth only about 1.5 billion years ago.
Oh my.
But it's supposed to have been there for 4.5, well, not quite 4.5 billion years.
That wrecks the evolutionary paradigm.
It's a serious problem.
All right, let's take it beyond that.
Next, out from Earth and the moon, we have Mars. Now, Mars, we don't really have a lot for age indicators, but it's an interesting illustration for the creation-evolution debate. Mars has a very, very thin atmosphere. And one result of that is that even though Mars is very cold, liquid water cannot exist on Mars' surface. Because the atmosphere is so thin, atmospheric pressure is very low, the boiling point of water becomes very low.
Yes.
So even though it's cold, water would boil away in a matter of minutes. Now, you might have heard in the news about all this evidence for water on Mars that keeps getting discovered, and that's an interesting subject in itself. Our point today is that evolutionists want water on Mars because they want life on Mars.
Yes, life to have developed outside, or have developed and evolved, originated, developed and evolved outside planet Earth to support the evolutionary theory. But let's see if that holds water.
Well, it doesn't. It doesn't hold water at all because water is impossible on Mars. Yet evolutionists are always trying to find evidence for it. To support their theory, they say that Mars used to have water and it was able to do so because it used to have a thicker atmosphere. Well, how do we know it used to have a thicker
Is there any evidence for that?
Well, there's not. Their explanation is that an asteroid hit the planet and caused some sort of catastrophe to remove the atmosphere that they need for their model.
But there's no plausible physics behind that.
There's not. And there's also an element of hypocrisy behind this as well, because the Earth is obviously covered with water.
Yes.
Over 70% of our surface, yet they mock creation believers for saying that there's evidence for a global flood. Obviously, there's a lot of evidence for a global flood, and we have the water here to do it, but they say it's unscientific to believe in a catastrophe to support your model. But what are they doing here with Mars? That's exactly what they're doing here. Absolutely.
Very interesting. Discuss that a little further. What other evidence do they claim for water, and what is the answer?
Well, the evidence is really inconclusive. There are some chemicals that we found that would seem to hint at water, and there's some that would seem to say there never was water. It's possible that Mars volcanoes have erupted in the past. They have enormous volcanoes on Mars, including the largest one in the solar system, for example. And we know that on Earth, when a volcano erupts, much of the material is steam.
Certainly.
Which sometimes comes down as torrential rain.
And there could be evidence of some flood flows.
Certainly.
On Mars.
As a result of that, yes. So it's possible.
But then the water evaporated. It's gone.
Exactly. Now, there is some water at Mars's poles, frozen in the form of ice, but you might have heard just recently that we actually have a lander on one of the poles now. And as it was digging for samples, it uncovered what appeared to be ice, which then evaporated. Thus, again, showing that water in its various forms does not last very long on the surface.
Spiro, everything that you've said so far is totally consistent with the creation model.
Yes.
But everything that you've said so far renders the evolutionary model very suspect.
Yes.
Let's go further.
Okay. Next out from Mars, we have Jupiter, which is the largest planet in our solar system. Jupiter poses a real challenge to evolution because the implications of the evolution model is that Jupiter cannot exist. Yet, here it is.
Here it is.
There are several reasons why it cannot exist according to the evolutionary model. One of them is that Jupiter would have needed between 10 to 100 million years in order to form from the nebula that you mentioned at the beginning of the program. However, the models say that the nebula would have dissipated in less than 5 million years. So Jupiter had no time
Major problem.
to form.
This requires a creator to be active in the solar system. And as we venture further out in the solar system, everything has a purpose. For instance, these massive planets that we have, I'm sure you would verify, actually sweep our solar system as a protective curtain of a kind for planet Earth, because this is the nurturing of living systems as designed by the Creator. All of this speaks loudly, astronomically, to a creator and a design and purpose.
Yes, absolutely.
Now, time is flying. Please take us further.
Okay. I wanted to discuss briefly one of the moons of Jupiter, which is here, Io. They call Io the pizza moon, as you can maybe guess by its appearance.
I can guess why.
And all the various blotches that you see are volcanoes. We've identified over 400 volcanoes in Io, about 150 of which are active at any given time. Io is an incredibly violent place. We've seen volcanoes shooting material 180 miles into space.
Wow.
The lavas it produces are hotter than Earth lavas, and one particular volcano on Io is actually more violent than all of Earth's volcanoes combined. It's a fascinating moon to study. The reason I'm mentioning it here is because the volcanoes produce an amazing amount of material. We watched just one of them produce 100 cubic meters of material per second.
I see where you're going. State that again. 100 cubic meters
per second.
Of volcanic expulsion per second.
Yes.
So if this were as ancient as the evolutionary model mandates, you would not have this activity.
Yes, for two reasons. First of all, the moon would have recycled itself through its own volcanoes over 30 times.
Over 30 times?
If it were 4.5 billion years old. The second problem is that from looking at these lavas, we can tell a lot of them have a very high density. There's a mixture of high density and low materials in the lavas. Well, what do you get when you take something that's even semi-fluid and mix high and low density? The high density sinks.
Certainly.
And low density floats.
But the fact that there's high density mandates recency.
Yes.
So we're taking the physics, the real physics, that can be computerized and coming to a deduction of recency and design.